Welcome to the Podkey summary of Extend Reality Composer Pro 3 functionality with Xcode from WWDC 2026. Today's thread is all about turning Reality Composer Pro from a nice editor into something much closer to a custom toolbench. The big idea is that developers can plug in their own components, systems, shader controls, animation actions, and even script graph nodes. So artists and designers can work directly in the editor instead of bouncing back and forth to app builds. And underneath all that, there are some very practical wins too, like better Git merges for reality files, and the ability to debug your plugin code live inside the editor. The foundation here is a plugin setup that links the editor with an Xcode project. A custom framework, in this case, RCPCD. Custom Components Framework gets built as a dynamic library and loaded by Reality Composer Pro 3 at runtime. That matters, because it means the editor can pick up brand new functionality right in the UI, instead of treating everything custom as something that only exists later in the app. To make that work, there's a plugin class that adopts the Reality Composer Pro plugin protocol. In its setup method, it registers the custom components and systems the editor needs to know about. Then there's a C-exported factory function, create Reality Composer Pro plugin, so the editor's loader can actually find and instantiate the plugin. It's built in a separate Xcode scheme, it's signed, and when Reality Composer Pro loads it, the editor asks the user to trust the plugin before those custom nodes show up for artists. Which is a pretty reasonable checkpoint when you're literally loading outside code into your editor. Once the plugin is in place, the really nice part starts with custom components. Developers define Swift structs that conform to component encodable, so the data can live inside the reality file and be serialized cleanly. The example here is a cauldron component with something like a water level value, because that component gets registered through the plugin. Its properties appear in the inspector panel, just like built-in properties do. So an artist can click the object, tweak water level in the editor, and see the change immediately while the scene is running. That shortens the iteration loop a lot, because nobody has to rebuild the app just to see whether the water should sit a little higher or lower. A custom component by itself is just data, so the next piece is a matching custom system. That system iterates over entities carrying the component, reads the current water level, and moves the water mesh entity in real time. So now the number in the inspector isn't abstract anymore. It directly drives what the artist sees in the viewport. This is one of those workflow improvements that sounds small until you've lived without it. Instant visual feedback inside the editor is a lot more pleasant than making a guess, compiling, launching, checking, and repeating that loop until your coffee gets cold. It gets more interesting when that same setup reaches into shader graph materials. A tech artist can build a vortex shader in Reality Composer Pro's shader graph and expose parameters like rotation speed and vortex coefficient. Those parameters control the shape and motion of the water surface. Then the custom cauldron component is extended with matching properties, and the system grabs the shader graph material, computes the desired vortex shape, and writes those values back to the material every frame. So artists stay in familiar visual tools, but the effect can still be driven by low-level Swift logic. The payoff is that someone can adjust the vortex settings in the inspector and watch the shader react immediately, which is a very tidy bridge between visual scripting and code. The same kind of extensibility shows up in animation too. By implementing the entity action protocol and making the action codable, developers can define a reusable animation action, like set water level action. That action interpolates the cauldron's water level between a start value and an end value over time. It listens to the .updated animation event, calculates the current level from normalized time, and writes the updated value back into the component. Once the plugin registers that action, it appears in the timeline editor. Designers can drag it onto a track, enter the numeric parameters they want, and the sequencer handles the water level animation during playback. No script nodes required for that part, which keeps the timeline cleaner and makes the action reusable across scenes. For teams using script graphs, There's another shortcut here that's pretty elegant. Applying the @scriptable macro to a component struct automatically generates the schema that the Reality Kit scripting system needs. Instead of handwriting all the boilerplate registration code, the macro creates it for you. Then the plugin setup function adds that generated module to Reality Kit scripting on the main thread. After that, the component becomes available as a node in script graphs. So a designer can put together something simple, like a key press-driven graph that sets the cauldron's water level. And they're doing it with a code-defined component that now behaves like a first-class visual scripting element. That's a nice example of code and no-code tools meeting in the middle without making either side miserable. There's also a practical collaboration story here that's easy to overlook until a merge conflict ruins your afternoon. When a .reality or .rcp file is imported, it's stored as JSON on disk. That means standard git diff and merge tools can at least understand the file format at a basic level. But Reality Composer Pro also ships with a custom merge tool that understands the JSON schema, so it can resolve conflicts with fewer false positives than a generic line-based merge. For teams sharing scenes and assets, that can make a very real difference, because creative work tends to collide in source control at exactly the worst possible moment. And finally, debugging is much less awkward than you might expect. Because the plugin runs inside the editor, developers can set breakpoints in their custom system or action code, launch Reality Composer Pro, and attach Xcode's debugger to the editor process. From there, you can step through the live execution while somebody is tweaking assets in the editor. So if there's a logic bug in how a component updates, how an action interpolates, or how shader parameters get pushed into a material, it shows up right away. That saves a lot of time compared with rebuilding a full app, just to verify one small behavior. Taken together, this all paints a pretty clear picture of Reality Composer Pro as something teams can extend deeply, not just use as is. When custom code, artist-friendly controls, visual scripting, sequencer actions, source control, and debugging all line up in one place, the editor starts feeling less like a handoff point and more like the real center of production. And honestly, if your cauldron water can be animated, scripted, shader-driven, and merged in Git without drama, that's a decent day's work. This episode was generated by Podkey. Create your own at podkey.fm.